when we're dealing with fractions, oftentimes we can be referring to the same number using multiple different fractions. So fractions that look different but represent the same number, these are called equivalent fractions. So an example of equivalent fractions are 1/2, because half an inch is the same as 2/4 of an inch. If you think about the your ruler here, this is the half divider. We're going 1/2. Well, the fourth dividers are here, and so if I go 1 2/4, that's equal to 1/2. We could go to the eighths dividers, which are these. I would go 1 2 3 4 eighths, or the sixteenths we'd go 8 sixteenths. So those are all referring to the same length. We call these equivalent fractions. And one of the nice things about equivalent fractions is we can just change between them whenever we'd like. If we have something written as 1/2 and we'd rather have it with a denominator of an 8, we can just change it to 4/8. There's no requirement about when we can do that. We can just change it. All right, so to find equivalent fractions, what we can do is one thing, if you happen to know them, that's good. But in general, you're not going to know all of the equivalent fractions. To find these equivalent fractions, if you multiply both the top and the bottom of the fraction by the same number, you get an equivalent fraction. So here, if I have 2/3, and I multiply both the top and the bottom by 6, so 2 times 6 and 3 times 6, I end up getting 12 on the top and 18 on the bottom. This means that 2/3 and 12/18 are equivalent fractions. This means I can also do things like if I have 3/4 and I want it to have a denominator of 20, well, I can figure out how to do that. I have 3/4, and I want the bottom to be equal to 20. So I need to figure out, okay, what do I multiply by 4 to get up to 20? Let's see, 4 times 5 is equal to 20. But I can't just multiply the bottom by 5. I would also have to multiply the top by 5. We would get 15 over 20. Essentially what we're doing here, if you remember back to when I was talking about the beginning of this section, if we have something divided up into 4 equal parts, and you divide, and I have 3 of these. So I have 3/4. When I'm multiplying both the top and the bottom by 5, essentially what I'm doing is I'm subdividing each of these into 4 equal parts each individually. And you can see what that does is it makes the things I'm counting smaller. So it makes the denominator smaller. It makes it 20 parts in total. I added 1 extra dash in there if you count them up. But in any case, the total divisions here are now 20, and I am also counting more of them. I'm counting 15 of them because each of these individual divisions is smaller. So instead of there being 3, I now have 15 of the 20. So that's what, one way to think of why I'm able to multiply both the top and the bottom of the fraction. And equivalently, I can take and divide both the top and the bottom of this fraction by whatever number, and it gives me something else. So if I had 12 over 20, and I said, well, each of these numbers are divisible by 2, I'd like to deal with smaller numbers, I could do 12 divided by 2 and 20 divided by 2 to give me 6 over 10. Okay, well, I could go even further. I could say, well, they're still both even, so I could take and divide each of those numbers by 2 again to get even smaller numbers. And I could get 3 over 5. And so instead of writing 12 over 20, I could deal with 3 over 5, and it's smaller numbers, but you can see through this process that they are equivalent to each other. I chose to divide by 2 twice on both top and bottom. If you had noticed that both the top and the bottom are divisible by 4, you could actually have gotten there in one step. All right. Let's find the appropriate numerator for the following. If we have 5/8 and we want it to write it with a denominator of 16, let's think about how we would do this. I want to multiply the bottom by something to make it a 16. I want to multiply 8 by, well, 2 to get up to 16. So I have to also do that to the top. 5 times 2 is 10. So this, I would have to have a 10 over 16 in order for those to be equivalent. All right, 7 over 16 is what I'm starting with, and I want it to be something over 48. Well, I need some number times 16 to equal 48. Let's say, I don't happen to see what that is, but I said it before, whenever you're saying what number times something gives us 48, this is really asking a question of division. So it's really asking, what is 48 divided by 16 is 3. And you could verify that this works. 16 times 3, you can see, does give us 48. So that means I want to multiply the bottom of this by 3, which means I also need to multiply the top by 3. And that gives me 7 times 3 is 21. So that means I would have a 21 right there. Alright, now let's look at this one. You'll notice we're going from a mixed number to a fraction, and we're also changing the denominator of that fraction. So I'm actually going to have to take this in two separate steps. I'm going to go ahead and start off by converting the mixed number to the fraction. 1 2/3 going to a fraction. Well, converting from a mixed number to an improper fraction gives me 1 times 3 is 3. Plus 2 is 5. So I actually have 5/3. So now that I have the fraction as 5/3, I then want to convert this and say, okay, what number do I need to multiply both the top and the bottom of this by to get it up to 12? Specifically, I want to multiply this 3 by something to get it up to 12. I just have to do it at the top as well. So let's see. 3 times 4 is equal to 12. So the 4 is what I need. And 5 times 4 gives me 20. So it looks like this right here should have been 20 over 12.